This technique is called PCR. It's used to make 1 billion million copies of DNA in like 2 hours. So if you're going to run a gel, if you really just put one single strand of DNA in there, like from the tip of a hair, you're not going to see the results. The only see anything is to make 100 million billion copies of DNA. And this can do it really easily. Here's how it works. These sticks represent, say, a piece of DNA from a human. Let's say it's the pink part is a gene for making human insulin, and we want to make 100 million billion copies of that gene. Here's how we do it. We heat the DNA up in a little device. It takes like 30 seconds. Guess what happens when we heat it up? The DNA separates. The next thing we do is we cool it down to about 50 degrees, and the primers stick to the beginning of the gene that we want to copy. So we're going to have that primer stick there, and then we're going to have this primer stick here like this. Then we warm it up to about 70 degrees. The DNA polymerase copies all the way to the end, all the DNA letters. It happens here and it happens here. That took like 2 minutes to do that. That's cycle 1. Then we go to cycle 2. Guess what happens cycle 2? DNA heats up, it separates. So I'm going to separate the DNA. We cool it down to 50, and guess what's going to happen? The primers, we're going to cool it down to 50. The primers are going to stick like that. And we got one that's going to stick like that. But guess what here? We're going to have one that sticks like that. And one that's going to stick like that.
This is great. It's magic.
Then we warm it up to 70. DNA polymerase does its magic. Copies all the way to the end. Copies all the way. Oops, falls off. Stops. Copies all the way. Oops, falls off. Stops. Copies all the way to the end. That's 2 cycles. Third cycle, we heat the DNA up. It separates. Right? Like this. Separates. 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 Like this. All right? Then we add the primers. Guess what? The primer is going to stick there and go like that. And this one's going to stick way up here and go like that. And then guess what happens here? Stick there, stick there, stick there.
This is super cool.
Stick there, stick there, stick there.
But he's really hard to. I like this a lot.
Then we warm it up to 70. Enzymes copy, 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 copy. Now look at this part. This is the brilliant part. After only 3 cycles, 2 of them, this one, are the target DNA that we want. The next time we do it, we'll have 4 of these.
Wait, why can't you just start out with that?
Because you're starting with the whole DNA.
So you have to make 16 to get 4?
Yeah, but we've only spent 8 minutes so far. Okay? Now the next thing that happens is we go through the process. We double everything, but these increase exponentially.
Yeah.
So at the end of about an hour, we will have like 1 billion of these.
Oh my gosh.
This is the gene, exactly what we want.
It would be true.
We'll have a little bit of this, a little bit of this, a little bit of that. Now I got a quick video I want to show you, then I'll take some questions. Go ahead and grab your